Hey, Algebra 2. Okay, I was going to open with, hey, all you cool cats and kittens. This is Mr. Imperio, because one of my friends was like, you have to do that. And I totally chickened out, but I did it. But I didn't. So this is where my life has come. Okay, so we are starting 5-3 today. 5-3 is graphing. So we're kind of going okay, I'll say this. We're kind of going like all over the place a little bit with the beginning of chapter 5. And it's true. It feels like we're going all over. We did inverses, we did composition of functions, and we did exponential functions. That's what we're doing today. But it really is gearing us up for the next like 4 sections. And those next 4 sections are super important for next year in pre-calc. So it's something that like really doesn't go away. And this is kind of like building the foundation of what you need to know to get us through in the next sections. So, so let's start with an exponential function. An exponential function is a function where the exponent contains the variable. A is called the base. So if we look over here, f of x is equal to a of x. That is my parent function. That's super important. So if you guys kind of recall from graphing and our transformations that we did last semester, we are going to be applying the same type of information in this section too. So if you guys need to like pause me here and take a little bit of like a refresh into semester 1. So that was, I think that was chapter 3 where we started transformations. That's going to be super important because we're going to obviously like we're going to talk about it, but we're just going to apply the transformations here. Okay, so let's first talk about our parent function table. So our parent function table is really like changing, like depends on what my base is. And so my base here, like we're just going to use A, and A basically, A can be any number. So A can be any number. It can be a fraction, it can be a decimal, it can be a whole number, it can be negative, it can be any number that you pick. So we're only going to pick 3 x values. Again, remember your x values are really like that's your choice, but I'm just giving you a range of what you can use to get a good graph. And I'm just going to use -1, 0, and 1. And so that's not really like, that's never changes besides like the transformations. That's never going to change. Now the y is going to be dependent on what my base number is. But let's just use A and like look at what that's going to be with just A in there. So A to the -1 power. If I plug in a negative exponent, so anytime there's a negative exponent, what does that do to that number? Where do we move it to make it positive? And if you said to the denominator, you would be correct. So what this turns into would be 1 over A. So if the base was 2, 2 to the -1 power is going to be 1 over 2. Okay, anything to the 0 power. What is anything to the 0 power going to be? Well, anything to the 0 power, hopefully you guys remember, is always 1, no matter what the base is. Positive, negative, whole number, fraction, whatever it is. Anything to the 0 power is always 1. And then A to the first power, well, anything to the first power is itself. So it's just going to be A. So if it was like the base was 2, 2 to the first power is going to be 2. Okay, so the domain. Remember, the domain is thinking about all of my x values. And so what x values can we plug in to this expression and get something? So I want you to think, is there any x value that I can't plug in that would make this not work? Is there a positive, a negative, zero? So if you need to pause and think about that, pause and think about that. But really, the answer is no. There isn't a number that I can plug in that wouldn't make this work. Every single number would make this work. A positive number, if I plug this in, would get me an answer. Like, let's say we had an example and it was like 2 to the 5th power. That's going to get me an answer. 2 to the 0 power, that's going to get me an answer. 2 to the negative, that's going to get me an answer. Even if it's a fraction, a decimal, those are all going to get me answers. So the domain is all real numbers. Okay, so then the range. The range, remember, is my y values. That's my output. And so we're thinking, what type of number is this going to be, like the output? So if I plug in -1, I get 1/2. If I get 0, if I plug in 0, I get 1. If I plug in 1, I get 2. So what types of numbers can an exponential equation never be? Are there any? Maybe. Think about it. Take a second. Think about all the different types of numbers you could plug in here, and then what types of numbers is going to become our output, and what does that exclude? I will give you a hint. It does exclude sub. So if you've thought about it and you're thinking there are 2 types of numbers, if I plug in, no matter what, any number that I plug in, I'm never going to get an output of 0. You're never going to get an output of 0. You're also never going to get an output of a negative number. Now, that is assuming that the base is positive, which if the base isn't positive, that would be a transformation, which I think I applied down here on 2. But so we're always assuming that the base is positive. Any negative would be a transformation, which would then, of course, any transformation would change our range. So the range here is going to be 0 with a parentheses because it can't be equal to 0, 0 to infinity. Which means, okay, we have a horizontal asymptote. Remember, an asymptote is like a horizontal or vertical line. In this case, it's horizontal, where it's trying to get really close to it. Like it's really trying to get close to 0, but it never actually does. So my horizontal asymptote is at y equals 0. So if you guys have your parent function tables from the beginning of the semester, I'm actually going to add this in just in case you want to use that. You know, you have it in one place, but I'm going to use and plug in, have it underneath here. I'm going to plug in that information into my parent function table. So we had filled in all of these from before: linear, quadratic, absolute value, cubic, yada, yada, yada. And then I'm going to plug in the information for exponential. So the parent function for exponential is f of x is equal to a to the x power. Our parent function table, we always use -1, 0, and 1. And then it's 1 over a, 1, and a. Now I'm going to be using, and I'm going to be going off of if I were using 2 to the x power. So let's plug that in. Because really the graph always looks the same, like really similar. It's just a matter of where the specific points are. So if we have -1, that's at 1/2. If we're at 0, we're at 1. And if we're at 1, we're at 2. Now, I should have put in my horizontal asymptote to start with, but my horizontal asymptote is going to be at y equals 0. So that's a horizontal line at 0. So that's right here. And so that means it's never going to go below that line. Unless, like I said, there's transformations. But we're just thinking about the parent function right now. And then my graph looks something like this, like a curve a little bit. And then we can write our important characteristics. So first, it has a horizontal asymptote. At y equals 0. The domain is going to always be all real numbers. And then the range is going to be 0 to infinity. And we can just look at the graph and know, okay, nothing, 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 0, but it doesn't ever touch 0 because there's an asymptote there. And then it goes on forever. Now, if we were to look at that like on Desmos, you can see that no matter what, whatever the base is, the curve basically looks the same. So if I have like y equals 3 to the x power, it's the same thing there. If I changed it to, there we go. 4 to the x looks the same. It just is getting like basically stretched a little bit because of like a bigger number. So there you go. So that is your parent function table. If you guys have this, great. If you don't really need it, right? Because you can use this. Okay, so we're always going to be coming back to the parent function table, and then of course the domain, range, and asymptote. But really the biggest one I'm always going to be coming back to is the asymptote, because the domain and range, really I just look at my graph for those. Okay, so we're going to apply our transformations, and we are going to go through 1 and 2. First thing, whenever I'm doing transformations, I always want to think about what my parent function is. And so my parent function here is really just looking at what's the base. And the base is 2. So the parent function is 2 to the x power, which is going to help us figure out our first table. So my x values are always going to be -1, 0, and 1. And then you can either use like these y values. It's like a dogfight out there. You can use these y values, or there really isn't. That's terrible, but they're just like barking at each other. So you can plug it in, or you can use up here. So either way, if you want to just think like 2 to the -1 is going to be 1/2. Or if you want to remember 1 over a, the a is 2, it's going to be 1 over 2. I usually just plug it into the parent function. So 2 to the 0 power is 1, and then 2 to the first power is 2. Okay, so then we're going to apply our transformations. I have 2 transformations here, and I'm going to kind of go like refresh that process for you guys. So first transformation I see is that -1. That -1, is that within the function, or is that outside the function? And it's actually, if you're wondering, it's within the function. It's within the function because it's part of the exponent. It's part of that variable. It's attached to the variable. So this is within the function. When it's within the function, is it a change to the x, or is it a change to the y? And if you're saying it's a change to the x, you would be correct. Okay, and then we have the +3. Is the +3 within the function, or is it outside the function? And if you're saying outside the function, you would be correct. So when it's outside the function, is that a change to the x or a change to the y? And it's a change to the y. Okay, so we're going to use those transformations in our second table. So all of my x values, my original x values, are being changed with this -1. Now, when it's a change to x, are we going to do the same operation or the opposite operation? And if you're saying the opposite operation, you would be correct. So instead of this -1, we're going to add 1 to all of my x values. And that's for the -1. And then my y's, now I'm going to write the 1/2 as a decimal since we're going to graph it. It's just easier for me when, I think in terms of decimals. When something is a change to the y, are we doing the same operation or the opposite operation? And if you think the same, you would be correct. So we're going to add 3 to all of my y values. And then we're going to get our final table. -1 plus 1 is 0, 1, and 2. And then this is going to get me 3.5, 4, and 5. Now, before I graph this, I always want to graph my horizontal asymptote first. Remember, with your parent function, it's originally y equals 0. Well, we think, okay, it's y. What happened to all of our y values? Well, it was added 3 units. So that means my new asymptote is going to be at y equals 3. So let's graph that. That's one thing I need is a ruler. And I don't have a ruler. And we all know I'm a little OCD with that. So I'm going to use a Post-it. Okay, so y equals 3 is here. I'm always going to draw my asymptote first, so I don't go like below or above that line, depending on where the graph falls. Okay, so 0 is at 3.5, 1 is at 4, and 2 is at 5. And then it's always going to be this like curve like that. And that's your graph. So your horizontal asymptote, we already wrote, is at y equals 3. And then I want you guys to pause me here, think about what's the domain and what's the range. So pause, think a little bit about what those two values are, and then come back and check your work. So the domain is always from left to right. Left to right, it's going from -infinity to +infinity. The domain is never going to change. It's always going to be this all real numbers. And then the range is bottom to top. We go from lowest, there's nothing. It starts at 3, but it doesn't hit 3, and then it goes up for infinity. So 3 to infinity. Your range and asymptote, this number, whatever your asymptote is, should always be part of the range. Every single time. No matter what direction the equation is facing, always, it should be part of the range. The asymptote should be part of the range. Sorry, I lost my train of thought as I was speaking to you. Great. Okay, so let's look at f of x is equal, let's look at number 2. So my base here is a little different. My base here is a fraction, but it doesn't change anything we do when we're like setting up, applying our transformations. So my parent function, that's always my starting point. The base is 1 over 4 to the x power. Now I actually want to graph that for you guys. Oh, rogue highlighter. And I want to show you how a fraction base changes the graph. So that's like before when we were looking at 4 to the x. Now if I have 1 divided by 4, nope, it's not what I wanted. Let's do this. Raise it to the x power. It actually changes the direction of the graph. So when it's a whole number or anything greater than 1, from left to right, it's going to be increasing. And then when it's a like less than 1, so less than 1, it's going to be from left to right, decreasing. So let's actually write that because I think that's something that's really important for you guys to see. So first, when the absolute value of A is greater than 1, I feel like this is super blurry. I'm going to try and focus it, but I don't know if it's going to work. Oh, that worked. Okay, so when the absolute value of A, the base, right, is greater than 1, from left to right, yep. The graph will be increasing. Just like it was on this one. From left to right, it's going up. And then just the opposite, when the absolute value of A is less than 1, so that's basically any fraction that's less than 1, from left to right, the graph will be decreasing. Okay. Now, what's going to happen is you're not going to see the decreasing here because of one of the transformations. We'll get to that. Okay, so we have two transformations here. We have that negative, and then we have that minus 1. The negative, we're always thinking, is that within the function or is that outside the function? Remember, within is part of the exponent. Outside is not part of the exponent. So that one is within. So because it's within the function, is that a change to an x or a change to the y? And that one is a change to the x. Okay, and then we look at the minus 1. Minus 1, is that within the function or outside the function? And that one is with or outside the function. So because it's outside the function, is that a change to the x or a change to the y? And that's a change to the y. Okay, so let's start with our parent function table. So my x values never change. We're always going to just use -1, 0, and 1. And then I just plug this in. So 1/4 to the -1, it's going to actually flip it. So it's 4/1 or just 4. 1/4 to the 0 power, anything to the 0 power is 1. And then 1/4 to the first power is 1/4. Okay, so then we can apply our transformations. So when it's a change to the x, is that the same operation or is that the opposite operation? And that's the opposite operation. So because we're multiplying by a -1, we're going to divide everything by a -1. Now, something like we've talked about this before, dividing something by a -1 and multiplying something by a -1 gets you the same thing. So if you actually just multiplied everything by -1, it would be fine. Okay, so -1, 0, 1, we're going to be dividing all of these by a -1. Now, I want you guys to think, what is this -1? How is it affecting our graph? And if you remember, it's affecting our graph by reflecting the graph. Now, it's reflecting it over the y-axis. So it's going to take it, and instead of being like, it's decreasing because it's a 1/4. So instead of being like that, it's now going to be reflected. And so it should be like this, which is why I said over here, this one's not going to look like a decreasing. Okay, then that -1 is going to change all of our y values. I'm going to write as a decimal. And when it's a change to the y, is it a same operation or opposite operation? And it's the same. And then we can get our final table. Okay, -1 divided by -1 is 1, 0, -1, and then 3, 0, and -0.75. Okay, so then before we plot our points, I always want to plot my asymptote first. My asymptote, remember, always starts at y equals 0, and then we look to see what happened to all of our y values. Well, it was subtracted by -1, so my new asymptote is going to be y equals -1. So let's always graph that first. Just down here. And there is my asymptote. Now I can graph my points. So 1 is at 3, 0 is at 0, and then -1 is at -0.75. So my graph looks like this. Always going to be a curve like this. Depending on the direction is depending on the base and the transformations. So then pause me here. I want you guys to think about what's the domain and range of this one. So you should have thought about those. And the domain never changes. The domain is always all real numbers. Easy points there. And then the range is always bottom to top. So the lowest it goes, -1 to infinity. Remember, my range should always have the asymptote in it. So -1 to infinity. It's always going to be like your range is always going to be the asymptote to infinity or -infinity to the asymptote, depending on where the graph is. Okay, so we are going to go to the second page. We're almost done. And go with this. Okay, now it bums me out that we're not together because E, this natural base exponential function, is super cool. And cool in a way that like you're like, oh, it actually is cool because E is like a financial number, and usually like this is when I would go off on like a financial tangent, and here we are. So just know that it is used in like the finance world for interest. Often it's super relevant to like continuously compounded interest. So E is an irrational number. It's really similar to pi in the sense that, I got to put a piece of paper under this. Hold on. It's similar to pi in the sense that it's like an irrational number that goes on forever. And it's used so often that we had to put a symbol to it instead of using this like ongoing number. So with an approximate value of 2.71828, so on and so on and so on. If you guys look on your calculators, you have an E button. The button is if you do second division, that's my E button. And as you see, there it is. Exponentials with base E are called natural base exponential functions. Many real-world applications of exponential functions use base E. So the parent function of a natural base exponential function is just with the base E. So let's write that. So that would be f of x is equal to e to the x power. So my parent function table, really none of this is different. Like we didn't even have to do a different table or anything. But my x values are always going to use -1, 0, 1. And then my y values, well, e to the -1 is just 1 over e. Now, as a decimal, because, when I'm graphing, I like to think about decimals. We can just plug that into our calculator. 1 divided by e, remember that's the division sign, 0.37 approximately. And then anything to the 0 power is 1. And then e to the first power is e, which we always just approximate to be 2.72. The domain of any exponential is always all real numbers. It's a weird infinity, sorry. The range, nothing, like we don't have any transformation, so the range is still the same. And the horizontal asymptote, again, no transformations, so it's the same. Okay, so we're just going to do one example with e as the base. So what I want you guys to first do, what we're going to first do, and then I'm going to have you guys do the next part on your own. My first part is just thinking, what's my parent function? My parent function is e to the x power. So I just start by putting in my table, which we wrote up here. You'll often see me put like my parent function with the like 1 over e, 1, and e, and then I put the decimal form in the next one. So what I want you guys to do is pause me here. I want you to think about your 2 transformations, and I want you to apply them and get your 2 other tables. If you guys do 1, that's fine, but I want you guys to think about your transformations and then apply them and get your final table. Come back and check your work. Okay, so you should be done with this. If you just want to fast forward through my explanation and just check your work, do that. Like, do you in these. Like, I am so happy if you guys are getting it and understanding it and you don't need me to, walk you through it. That's great. But if you do need the explanation and you need the extra help, now's the time to get it. Okay, so the +2 we're thinking, is that part of the function or is that outside of the function? It's within the function. So that's always when it's within, it's going to be a change to the x values. And then that -1, is the -1 within the function or is it outside the function? And it's outside. So that's going to be a change to the y. Okay, so let's apply those transformations. So to all of my x values, we look, and then when it's a change to the x, remember we do the opposite operation. So because this is a +2, I'm going to subtract 2. And then to all of my y values, so 1 over e now is when I put in my decimals. That -1, remember we do the same operation, so I'm going to subtract 1 from all of these to get my final table. My x values are now going to be -3, -2, and -1. My y values, I'm going to use my calculator here because, I could do 0.37 minus 1, or I could just do it in the calculator. And that gets me -0.63. 1 minus 1 is 0, and 2.72 minus 1 is 1.72. Now I always want to get my asymptote. So if you haven't already thought about what your asymptote is, I want you to pause me here and think about what your asymptote is on your own. So think about the asymptote. We know parent function is y equals 0. We think, what happened to all of my y values? Well, they were subtracted by 1. So my new asymptote is at y equals -1. So I'm going to graph that. Oh, the sticky part is sticking to my hand. Okay. And then I'm going to plot my points. -3 is at -0.63. -2 is at 0. -1 is at 1.72. So my graph looks like that. And then what I want you guys to do, think about what the domain, range, we already know that the horizontal asymptote is at -1. So take a second, think about the domain and range on your own, and then come back, check your work. Okay, so you should have thought about it. The domain, always, all real numbers. No changing here. And then the range, lowest to highest, -1, always involves my asymptote to infinity. The only time it would be negative infinity to this is if it was reflected over the x-axis, and so it was going down, and that would be a negative out here. Okay, so that's it for 3. That's it for our notes. This is the first part of 5.3. We're going to finish 5.3 in the next video. So that's it for graphing, though. So I hope you guys have a great day. You know, if you guys need any help, I'm always there for office hours. I also posted like a cell phone number. So if you guys need me, you can always text me or call me on that. Just if you text me, please put your name, like who it is that you're texting me, because I like don't have your phone numbers. So I need your name. And that's it. So I hope you guys have a great day, and I will talk to you guys soon. Goodbye.